one propanol. Where's the alcohol group? One propanol. It's off the first carbon. Get it? There's the only other type of propanol is 2-propanol, because where's that alcohol? Well, that's off the second carbon, right in the middle. Okay? All right. What do you think is going to happen with this one? Now, this one should behave differently. And I'm really pissed that my methanol didn't work the way it's supposed to. That one should have burned really, really fast. And then as we get closer and we make the molecules bigger, it should have burned slower and slower and slower. All right? Here we go. Okay, that was perfect. That's how they should have burned. The first one should have went really fast, and it didn't. Okay, and then the second one a little bit slower, and then the really cool one here is the last one, which is butanol. And that's a really big molecule. All right, this stuff is really funky. Butanol, if anybody's used a butane lighter before, all right, a Zippo. Everybody used a Zippo? And you get that, let me see it. And you get that stuff. Oh, that's so cool. It works good. I usually don't let people film my stuff. I shouldn't.
I won't film.
No, I don't mind here because nobody's in the picture or anything like that. But Justin should have goggles on sitting where he is. Got my glasses. All right, you ready? All right, this one is a big giant molecule. So what's going to happen here? Are we going to have enough oxygen in there to break apart the butanol into CO2, CO, and water? No. So what's the limiting factor right here? Oxygen. You get that? All right, that's the point. So if this one works, hopefully it will. If not, I'm going to have to mix it up. There's a solve. Holy crap, look at that. It is. All right, so that one is butanol. Now I'm going to mix that with a little bit different stuff because that should have worked better than that. So I'm going to add a different alcohol, but you'll still be able to see it. All right. Now, here's the problem. What if I capped it? What if I put a top on here? All right. Now, then we go to the gas laws, right? Because we're going to have a huge amount of pressure built up on the inside, and it won't work. Now, this one's a little bit different because now we already burned it. I don't even know if it'll work because it's all CO2 in there. So it might not even work. It might not even work. The only place it will burn is up at the top. And this is really dangerous now because if it sucks in oxygen, all right, we could get a lot of oxygen in the bottom. God darn it, this works so good and I should have mixed it. I should have mixed it right off the bat. All right, I'm just going to drop this one in. So you can see that oxygen is the limiting factor right there, big time. All right, and every time the flame goes down, it's actually sucking in a little bit more. Oh, look at that! All right. Every time it goes down, it actually sucks in just a little bit more oxygen. And this is what you guys were going to be doing. You were going to light all 4 of them on fire, and it's really cool. You look around the room and see that the changes in it. All right, that's really cool. So you can kind of see that the oxygen is not enough to break it up. And guys, if we balance the chemical reaction, you'd end up with a huge mole ratio, like 25 to 1. Okay, so it takes a whole bunch of oxygen to get it going.